This will be part 2 of section 5.4, and it's the last features that we need to learn how to find on the graphs of fractions. And problems 33 through 48, the instructions ask me to find a horizontal asymptote. A horizontal asymptote is a line that has an equation y equal to some number that the graph gets attracted to on the far left edge of the graph and the far right edge of the graph that doesn't really control the graph in the middle, kind of close to the origin. So this is just a horizontal line with the equation y equal to some number that the graph gets pulled to as you get to the far left edge and the far right edge of the graph, but not around the origin. There's a strategy for finding the horizontal asymptote, and it is completely dependent on the x term in the numerator that has the highest exponent and the x term in the denominator that has the highest exponent. In problem 34, the x term in the numerator that has the highest exponent is the 6x to the first term, and the x term in the denominator with the highest exponent is the 2x to the first term. There's a little piece of paper that I stole from the internet, or something I copied from the internet, to explain how to find the horizontal asymptote of the graph of a fraction. And it very specifically says when you're looking at a fraction to specifically find the term with the highest exponent in the numerator, find the term with the highest exponent in the denominator, and then compare those exponents. If the exponent in the denominator is bigger than the exponent in the numerator, then the x-axis, or y equals 0, is the horizontal asymptote. If the highest exponent in the numerator is equal to the highest exponent of the x term in the denominator, then the horizontal asymptote is the line y equals, and you divide the numbers in front of the terms with the highest exponent. And if the highest exponent in the numerator is bigger than the highest exponent in the denominator, you don't get a horizontal asymptote, you get a slant asymptote. I might have run through that so quickly that it wouldn't make any sense, and that's okay. I'm going to go through this sheet a bunch of times and you'll get it down. In this particular problem, to find the horizontal asymptote, I look at the term in the numerator with the highest exponent, and that's the 6x to the first power term. I also look at the term in the denominator with the highest exponent. That's the 2x to the first power term. Because the term with the highest exponent in the numerator has the same exponent as the term with the highest exponent in the denominator, then there's going to be a horizontal asymptote, and I divide the coefficients of those x terms to get the horizontal asymptote. So for problem 34, the horizontal asymptote can be gotten by writing y equals, and I'm going to make a fraction, and the coefficient of the x term with the highest exponent is going to go in the numerator, and the coefficient of the x term with the highest exponent from the denominator is going to go in the denominator. That's going to give me y equal to 6 over 2, which reduces to y equal to 3. The answer to problem 34 is going to be y equal to 3, and let me show you graphically what happens for that. I'm going to graph this function, and I'm going to graph the horizontal asymptote of y equal to 3. Unlike with vertical asymptotes, I can enter this without any trickery. So I'm going to enter the function y equals clear parentheses, put the numerator in the parentheses, and put the denominator in a parentheses. I'm going to zoom standard. This is going to be the graph of the function without the horizontal asymptote. And now I'm going to add in the graph of the horizontal asymptote by going y equal to 3 without any multiplying by 1,000, because it's a horizontal line. I don't need to do any trickery. And you'll see that off to the far right edge of the window, the graph starts getting closer to that line. Similarly, off to the far left edge of the window, the graph's going to get closer to that line. If I make the window bigger, meaning make it go further to the right and further to the left, I'll see better the impact of that horizontal asymptote. So if I change my window and maybe change the x's to be minus 30 to positive 30, when I graph it, I'll see more clearly how that horizontal asymptote, how the graph is drawn to that horizontal asymptote. You'll see that eventually the line gets so close to that horizontal asymptote that you can't even distinguish the graph from the horizontal asymptote. So I don't need to graph any of these, but I can. And a horizontal asymptote, in the middle by the origin, the graph doesn't have to be close to that horizontal asymptote. But as I go far off to the right and far off to the left, the graph will get really close to that horizontal asymptote. So you should be able to stumble through problem 33 pretty nicely, hopefully. And I'll go on and do problem 36. And in problem 36, in the numerator, I'm looking at the term with the highest exponent, which is 3x to the first power. In the denominator, I'm looking at only the term with the highest exponent, which is x to the second power. In this case, the highest exponent in the denominator, with the x squared, is bigger than the highest exponent in the numerator, which is the 1. That's this case here. If the highest exponent in the denominator is bigger than the highest exponent in the numerator, or conversely, if the highest exponent in the numerator is less than the highest exponent in the denominator, then there's no algebra to do to find the horizontal asymptote. The horizontal asymptote is the equation y equal to 0. That's what this little saying says here. So when I go to do problem 36, my answer is not going to require any algebra because the bigger exponent is in the denominator. It's just going to be the horizontal asymptote is y equal to 0. And let me graph this to show you that that's the case. I'm going to graph the function parentheses 3x, I think that was a minus 18. I hope it was. Maybe it was a plus 18. 3x minus 18 divided by x squared plus 5x plus 6. And I'm going to go back to a zoom standard. And the x-axis is going to be the horizontal asymptote. So this graph should get really close to the x-axis as we go far to the right and far to the left. Already as I'm even at x equal to 4, the graph is already indistinguishable between the graph and the x-axis on my calculator. If I went a little bit further off to the left by changing my x-min to like maybe negative 20, the graph is going to get really, really close to the x-axis. So when the bigger exponent is in the denominator, there's no algebra to do for the horizontal asymptote, and the horizontal asymptote is the x-axis, which has the equation y equal to 0, and the graph will ultimately get indistinguishably close to the indistinguishable from the x-axis, which has the equation y equal to 0. Your problem 35 should work just the same. I'll move on and do problem 38, and you can do 37. To do 37, I look at the highest exponent term in the numerator and the highest exponent term in the denominator. I ignore the rest of the numerator and the rest of the denominator. Because the highest exponent term in the numerator has an exponent of 2, which is equal to the highest exponent term in the denominator, I'm going to find the horizontal asymptote by dividing the numbers in front of those x's. The numbers in front of the x in the numerator I can see as a 3. The number in front of the x in the denominator I can't see, but it's implied 1. The horizontal asymptote, which I'm going to abbreviate HA, is going to be y equal 3 divided by 1. And my answer to problem 38 is the horizontal asymptote is going to be y equal to 3. You should be able to do something similar for 37. I'll move on to 39 and 40. And in 39 and 40, I'm just looking at, in the numerator, the term with the highest power of x, ignoring the rest of the numerator. In the denominator, the term with the highest exponent of x, ignore the rest of the denominator. If the exponent in the numerator is tied with the exponent in the denominator, then the horizontal asymptote you get by just writing y equals, and you make a fraction that has the coefficients of those x terms. And that's all there is to do for problem 40. Similarly, that's all there's going to be to do for 39. But in 39, you have to think of the terms in the numerator and the denominator for the x squared terms of having 1s in front of them. 42 is tricky because the numerator doesn't have an x to the first power term. You can think of the numerator as being 0x plus 2 over x minus 8 if you want to. Or better yet, we can think of the numerator being 2x to the 0 over x minus 8. So there's two different ways to consider the numerator in problem 42 because it doesn't have an x term. You could give it an x term of 0x to the first, and that would simplify to 2 over x minus 8 because 0x is 0, and that would leave me with a 2 if you simplified that. Or you can make it 2x to the 0 over x minus 8 when you think of reimagining the numerator with an x, because x to the 0 is 1. This would mean 2 times 1 over x minus 8, which is 2 over x minus 8. Each one of these would give me the same horizontal asymptote. The top version, I'd have to look at the term in the numerator with the highest exponent, the term in the denominator with the highest exponent, and I've made these have the same highest exponent. The numerator is a 0x to the first, the denominator is a 1x to the first. The horizontal asymptote when there's a tie between the exponents is going to be y equals, and you divide the coefficients. In this case, it's going to be y equals 0 over 1, and that simplifies to 0. So looking at problem 42 with the numerator written like this, you get y equals 0 for the horizontal asymptote. Looking at problem 42 with the numerator like this, the highest exponent term in the numerator is 2x to the 0. The highest exponent term in the denominator is x to the 1x to the first. When the highest exponent in the numerator is less than the highest exponent in the denominator, the horizontal asymptote is y equal to 0, and there's no algebra to do. So this way to look at this also gives me a horizontal asymptote of y equal to 0. When there isn't an x term in the numerator, the horizontal asymptote is always going to be y equal to 0, regardless of how you try to rationalize it. So when there's no x in the numerator of a fraction, you don't technically have to do any algebra. You will always get a horizontal asymptote of y equal to 0. So immediately, if I was doing 41, I just glance at that. If I'm asked to find a horizontal asymptote and there isn't an x in the numerator, I can default and say the horizontal asymptote is y equal to 0, or I can consider that fraction 0x plus 6 over x minus 6, or I can consider it 3x to the 0 over x minus 6. Both this one, if you do the algebra, that's similar to this, or this one, if you do the non-algebra, that's similar to this, will give you the y equal to 0 for the horizontal asymptote. For problems 43 and 44, I look at the terms in the numerator with the highest exponent and the term in the denominator with the highest exponent, and I ignore the rest of the fraction. Because the denominator's exponent is bigger than the numerator's exponent, the numerator's exponent is less than the denominator's exponent, the x-axis, or y equal to 0, is the horizontal asymptote, and there's no work to do. So for 44, the answer is the horizontal asymptote is going to be y equal to 0, and anytime the highest exponent in the denominator is bigger than the highest exponent in the numerator, you get y equal to 0 for the horizontal asymptote. For problem 46, I ignore everything in the denominator and the numerator that isn't the highest exponent. The highest exponent term in the numerator is the 3x, which is really 3x to the first. In the denominator, the highest exponent term is x squared. The highest exponent in the numerator is less than the highest exponent in the denominator. There's no algebra to do to get the horizontal asymptote. It's just going to have the equation y equal to 0. My answer to 46 is the horizontal asymptote is going to be y equal to 0. Same deal for 48. I kind of overkilled these. Let me do your 47 because it's different. For 47, your term with the highest exponent in the numerator is the 5x squared. Your term with the highest exponent in the denominator is the x squared, which is really 1x squared. When there's a tie between the numerator and the denominator, you divide the coefficients of that term to get the horizontal asymptote. So in 47, the horizontal asymptote is going to have an equation y equal to 5 over 1, and that fraction reduces to y equal to 5. So that would be the answer for number 47. The last group of problems between 49 and 58 said find the equation of the slant asymptote. In each of the problems between 49 and 58, if you examine the highest power term in the numerator and the highest power term in the denominator, the numerator's exponent is going to be bigger than the denominator's exponent. In this case, there's no slant asymptote. There's no horizontal asymptote. I get a slant asymptote. So for each one of these problems, the numerator, its term with the highest exponent, has a bigger exponent than the denominator's term with the highest exponent. And then instead of getting a horizontal line that the graph is drawn to, you get a slanted line. If I graph the function in problem 50, let me do 49 because I destroyed the function. Let me graph the function in 49, going parentheses x squared plus 5x plus 1 divided by parentheses 2x plus 3, and do a zoom standard. You'll see that this graph it won't follow a horizontal line. It's going to follow a slanted line because the graph doesn't flatten out. It follows a slanted line. So in problem 49, the highest exponent term in the numerator is going to be that 1x squared. The highest exponent term in the denominator is this 2x. Because the highest exponent in the numerator is bigger than the highest exponent in the denominator, you don't get a horizontal asymptote, you get a slant asymptote. You find the equation of the slant asymptote by just reducing the fraction that has the highest exponent term in the numerator divided by the highest exponent term in the denominator. So to find the equation of the slant asymptote, the diagonal line that this graph gets attracted to, I'm just going to simplify the fraction that has the highest power term in the numerator divided by the highest power term in the denominator. For this, I'm going to divide by canceling. I wrote the 1x squared as 1 times x. I'm going to cancel my x and get 1x over 2 is the slant asymptote. This would be the answer to find the equation of the slant asymptote for problem 49. Let me go ahead and graph that for you and show you. I'm going to graph that in y2, 1x divided by 2. And I'm going to graph that, and you'll see that the graph gets really close to that line as I go far out to the left and to the far right edges of the graph. In the middle of the graph isn't anywhere close to the line. If I make my window bigger by making the x's go further to the left and further to the right, then I'll see more the impact of this slanted line. You'll see the graph getting really close. The bigger I make the window, the bigger the graph, closer the graph gets to that slanted line. So this is the answer for number 49. It may look odd to you. It would have been completely okay if I would have written 1/2 x by moving the x to the right of the fraction. It also would have been okay if I would have just written x over 2 and not have the 1 next to the x. Let me move on and do problem 52. In problem 52, the term with the highest exponent in the numerator has an exponent of 2. The term with the highest exponent in the denominator has an exponent of 1. When the highest exponent in the numerator is bigger than the highest exponent in the denominator, there isn't a horizontal asymptote. There's a slant asymptote, or we can call it an oblique asymptote. And you get the equation of the slant asymptote by just physically dividing those terms. So I'm going to take the highest exponent term in the numerator, which is 8x squared, and divide it by the highest exponent term in the denominator, which is 2x. Let me reduce this fraction by writing the numerator without the squared and canceling. I'm going to cancel the 8 divided by 2 and get a 4. I'm going to cancel the x's and get rid of the x in the denominator. When I do my canceling, I'm left with a 4 in the numerator when I cancel the 8 by 2, and an x in the denominator from the 1x that doesn't cancel. My slant asymptote answer for problem 52 is going to be y equal to 4x, which means if I graph the fraction and I graph y equal to 4x, that the graph is going to be drawn to that. I don't know how well this is going to show up, but let me try to do that real quickly. I'm going to graph the fraction 8x squared minus 6x minus 3 divided by 2x plus 5 in my y1. And in my y2, I'm going to graph 4x, and I'm going to do a zoom standard. And we should see that my graph of the fraction, which gets drawn first, oh gosh, we don't see it so well at all. I think I have to make my window incredibly bigger. This graph should have two halves. I only see one half, and I can't see at all the effect of that horizontal asymptote. I think to see this, I have to make my windows obnoxiously large. Let me make my y's and my x's at the 50s, just to try to show you the effect of this asymptote. Oh, I'm still not seeing anything. I could spend all day trying to find a window that shows the asymptote. Let me try to do that real quickly. Or I can just say it actually does track that asymptote. Here's a window that's better for the graph. That now you can see that the graph gets closer to the asymptote. So the graph are these kind of Nike swooshes, and the asymptote, you can see how the graph gets close to that asymptote. It gets kind of hard to sometimes find a window that is going to show the slant asymptotes well, but you can, if you play enough, get the slant asymptotes to show on a window. It just takes a lot of work, and it's not worth my time to do that usually. So for each one of these, there's going to be a slant asymptote, and you get the equation of the slant asymptote whether you can see it or not via the graph by just forming a fraction with the highest exponent term in the numerator divided by the highest exponent term in the denominator. Then you reduce those fractions. For problem 54, the highest exponent term in the numerator has an exponent of 2. The highest exponent term in the denominator has an exponent of 1. When the highest exponent in the numerator is bigger than the highest exponent in the denominator, we just divide those terms to get the equation of the slant asymptote. So for 54, my slant asymptote can be found by writing y equals to 3x squared over 12x. I'm going to consider that 3x times x over 12x. I'm going to reduce the 3 and the 12. 3 divided by 3 is 1. 12 divided by 3 is 4. And I'm going to cancel one of the x's. And I'm going to get, for an answer, y equal to 1x over 4 for my slant asymptote, which is the same as 1/4 x. If I move the x out to the right of the fraction, it's also the same as just x over 4. So any one of these for an answer to problem 54 would be fine. All of these are equal to each other. Y equal 1x over 4 equals to y equal to 1/4 x. The x can be moved out front, or I can drop that 1 and leave it x over 4. Your answer for 53 should be similar. And we just have two problems left to do. For problem 56, the highest exponent in the numerator is bigger than the highest exponent in the denominator, so I get a slant asymptote. I need to divide the highest exponent term in the numerator by the highest exponent term in the denominator. To do this, I'm going to write the problem without the exponents. I'm going to reduce the fraction 8 over 6. 8 divided by 2 is 4. 6 divided by 2 is 3. And I'm going to cancel 2 of the x's. My answer to problem 56 is going to be y equals, what's left in the numerator is a 4x. What's left in the denominator is 3. That's how I'm going to leave mine, but I could have written it y equals to 4/3 x as well. So give 55 a go. I'll do 58. In 58, the highest power in the numerator is bigger than the highest power in the denominator, so I get a slant asymptote by dividing y equals x cubed over x squared. I'm going to write the x cubed as x times x times x. I'm going to write the x squared as x times x. I'm going to cancel. I've canceled the entire denominator, so I don't need to write a fraction. What's only left in the numerator is an x. My slant asymptote for problem 58 is going to be y equal to x. My